Good evening, beta. Good evening. Just waiting for everybody to come in. Another 2 minutes, okay? Loud and clear.
Okay, okay, sir. Loud.
Okay, class, time to start. Here is the dry docking assignment. Please let me know if anybody has any doubts in question number 3 and 4. Otherwise, we'll continue with Simpson's. Leave question 5 and 6 for you to complete today. Everybody is good with 3 and 4?
Yes, sir. Yes, sir.
Okay. So I minimize this and we go back to our Simpson's rules. So guys, yesterday, let me have a quick recap. I said yesterday that Simpson's rules is nothing but a simplified technique of achieving the process of integration. Okay, there are three rules. Right now, we had discussed until the class got over yesterday. We had discussed only rule one. They are named as rule 1, 2, and 3. Okay. What is important before the introduction to this thing run up to the Simpsons rules? We had a relook at the concept of moments. Why? Because we need the moment of weight, mass, area, or volume whose geometric center is required from a reference axis. So we would need the moment about that very axis or some other convenient axis. Okay. Whether we choose that axis about which answer is required or we choose an alternative axis, it's a matter of convenience. So don't think that why should we only be this, why not something else. You can always, only thing is that may add few more steps to your work. So it's only a matter of convenience to make the things easier for you, especially you will have the time in the exam. So it will be, you'll find the axis from this, which distance to the geometric center is required. Is it one of the extremity of the diagram? Extremity of the diagram, I mean, is when it's a vertical bulkhead or a vertical structure, then the extremity would be the top of the bulkhead or the bottom of the bulkhead. If it's area of a deck, extremity can be forward, aft, end of the thing. Okay, so basically we'll have to, if you're talking of LCF, LCG, AB, then you know you need the longitudinal thing. Then you'll have to take the axis. Is it essential that we take the axis at the extremity? No, not at all. Then why am I pushing you to take the axis at the extremity is because if you take the axis to one of the extremities, then all moments will have same sign and they can just be added without any thinking required. If you do not take an extremity, suppose tomorrow you take midship as the reference axis. Suppose you take somewhere at the middle height of the bulkhead as the axis. Then to avoid getting into algebraic sum of the moments, we prefer to take the axis at one of the extremes. Am I clear, beta? Yes or no? Clear? Guys, have you understood what I said or any gap?
Yes, sir. Understood.
Okay.
Good, sir. Okay.
O-
Level.
uh,
Like
okay.
in yesterday question.
No, no. Have you understood what why the preferred choice of axis? But have you understood that what I just now said?
Yes, sir. Yes, sir.
Now, what is your question? Tell me.
So my question is about the yesterday question level.
You
Like, yes,
come closer to the mic. Your voice, your volume, it's very feeble. Come closer to the mic. Huh?
yes, sir. Now I am audible, sir.
Yes, yes, yes. Go ahead.
Yes, yes, sir. I was talking about like yesterday we done a question,
Mhm.
question number three. We
Yeah.
take the like axis on the bottom extremity, like as you told us to take
Yes.
it. It's better we will take from the extremity of both ends.
Why? So just now I said, let me just interject and then you can continue. I recommended that you take the extremity, the axis at the extremity. Now that bulkhead had two extremities, either the top of the bulkhead or the bottom of the bulkhead. So ideally, we should have chosen between the two. The questions wanted the distance from the bottom of the bulkhead. That is why between the two, we opted for the one at the bottom of the bulkhead. Now go ahead.
Yes, sir. And bottom of the bulkhead when we are taking, it's very easy to me to take a levers easily. But when I was calculating from the top, sir,
Yeah.
I'm not able to put the levers.
Why? let me just do it here right away. Why you're not able to do the levers? Let me just go on this itself a back one page.
Yes,
If you have the question, don't worry about the question. Let me just explain to you. It was something like this. It was something like this. Correct, beta? And you are
correct,
saying
sir. Correct.
I'll take the axis here, right?
Right, sir.
Okay. Okay. If this is y1, this is y2, this is y3, this will y4, this is y5, this is y6. So
Yes, sir.
lever for y1 will be 0h, for y2 will be 1h, 2h, 3h, 4h, and 5h. 1, 2,
Yes,
3, 4, 5, 6, and 6h. No, Z 1, 2, 3, 4, 5, 6, or 5h, up to 5h, right?
yes, sir. 5 inch.
Correct. And
Correct, sir.
lever for this one, if you want to take, but then you don't have to, if you want to take this lever, then it will be 1, 2, 3, 4, 5. 5 to the 10, 10 plus zero point 0.5, it will be 10.5 meters, right? It will be absolute number.
Yes, sir.
So either you can, but why you want to take about the top? It's okay. So what you can
No,
do
just
is, no, no. So
yes, sir.
what you can do is just leave this part out. You just calculate A1, correct? And
Correct, sir.
calculate D1 XX, which is XX is on the bulkhead top, right? Correct?
Perfect, sir.
Okay.
Perfect, sir.
Then you calculate D1
Yes, sir.
YY.
Got it.
YY is now the bottom one. D1 YY. What will that be equal to? The total height of the bulkhead minus D1 XX. Okay, beta?
Okay, sir. Okay, sir. Now I get it.
Okay. And you
Yes,
can get D2YY, that will be zero point 0.5 meters. And then you'll get the same answer. Okay.
yes, sir. Yes, sir. Okay, sir. Thank you. Thank you, sir. Thank you,
Okay,
sir.
beta. Yeah. Okay. Okay. So what I said, secondly, is I said is liver. When we are dealing with the ordinates, so now I'm only talking specific. I'm not giving funda. I'm just talking specifically about the question. When we are talking of liver, never ever. You see, you get so used to this thing, 1H, 2H, 3H, or whatever. Don't get used to things. Let it be logical every time. What is the liver? Identify the midpoint of the ordinate and and if it's an area, identify the centroid of the area and find the perpendicular distance of that point from the reference axis. Whether the reference axis is on top or bottom, left or right, wherever it is, you take the distance. From there, you'll get the livers. Okay. Now, another thing is reading of the question very, very carefully, guys. Most of the mistakes in Simpson's rules happen because of the careless reading. Where are the ordinates given from? Are they given from left to right, right to left, top to bottom, bottom to top? Be careful. Okay. Secondly, what is actually required to be calculated? Question has to be read very, very carefully. Diagram holds the key. Livers will never be wrong if you keep looking at the diagram when you are assigning the livers. Livers will be invariably wrong if you are not being aided by a diagram. Sometimes people feel it's so simple, why should I make a diagram? Please don't fall into that trap. Livers are the easiest to be picked up from the diagram. Yesterday, I showed you how the bulkheads can be shown in a diagram. When it comes to water plane area, I will show you how water plane can be shown as a diagram. And I have not digitized all the diagrams intentionally. Why? The stage will come where I'll start hand drawing so that you don't feel that how can I draw? You already had drawn it, so you could show it. No. Once you develop the habit, it's a question of intent. It's not the question of capability. These diagrams are not very difficult. It's a question of intent. If your intent is to make a suitable diagram, very quickly you'll pick up and you'll start making the relevant diagram. So please don't cut short on the diagram. Whatever time you spend on the diagram is an investment, and you will save that time by way of ensuring accuracy in the one first go itself. And it will also set in clarity of the question. Guys, any more questions on the? So I have repeated whatever I said yesterday. If you have any doubts, let me know. Okay. Then we had done two questions on rule one. What was the applicability criteria of the rule one? Minimum number of ordinates, 3. Thereafter, that means if it is more than 3, total number of ordinates is odd. Then rule 1 is applicable. What are the Simpson's multipliers for rule 1? When you have minimum ordinates, the multipliers are 1, 4, 1. Thereafter, as it gets more, you'll start with 1, you will keep filling in with 4, 2 as many times as required and end with 4, 1. Simpson's coefficient for rule 1 is 1 by 3. I'm sure everybody is comfortable with this part. We had done two questions using these values. Correct, guys? Right, guys? Okay. Now, applicability for rule 2. Process for rule 2, table structure, everything will remain same. Only the applicability criteria will be different. Simpson's multipliers will be different and coefficient will be different. Applicability criteria for rule 2. It is first applicable with minimum ordinates of 4. Okay. If the number of ordinates is more than 4, then the total count of the ordinates must be one of these numbers, 4. And then you keep adding 3, 3, 3, 3. That means 4 plus 3, 7, then 10, then 13, then 16, and like this. How many ordinates will they give you? Maybe 10, 12, 10, 13, 16. So instead of making a arithmetic progression formula and then forgetting it, just keep it simple. 4 plus 3 plus 3 plus 3 plus 3. Write these 5, 6, 7 numbers. If it happens to be one of these, then rule 2 can be deployed. Now, some of you may feel that some of these numbers here, like 7, 13, 19, and some thereafter, they also happen to be odd numbers. So in these cases, like 7, 13, 19, both rule 1 and 2 are applicable. Now, unless the question specifically says which rule to use, then you are bound by the question. Or if you see any distinct advantage in using one rule, that means it makes the process simpler, then you prefer that rule. Otherwise, you are at liberty to use either rule 1 or 2 where both can be used. Please remember, answers would not match. Why the answers would not match is because both rules have been derived using different equation for the curves. So the starting point of the derivation for both the rules is different. Therefore, results obtained for the same question by rule 1 will be different from that obtained by rule 2. You can do either of them, use either of them. Both will be taken as right. If you want to ask me which one is more accurate, there is no way to say which one is more accurate. It will depend. If the shape of the ship in that part where the rule is applied, if it is closer to the second order, it will be more accurate. If it is closer to third degree equation, rule 2 will be more accurate. And there is no way you and me can figure out actual curvature will be closer to which one. So, as far as we are concerned, we do not know which one will be more accurate. Both will be as good or as bad as we are concerned. So you will be at liberty to use rule 1 or 2. But if you want to match answers, please match with the person who has used the same rule as you have used. Am I clear, guys, what to do in case where both rules are applicable? Clear? Clear, class?
Yes, yes, sir, yes.
Now, Simpson's multiplier. Obviously, if there are minimum ordinates 4, there will be 4 Simpson's multipliers, and they are 1, 3, 3, 1. If you have more than four, then obviously three is getting added. So you'll have three instead of four, two being pairs. Here you'll have in back three. They will repeat. You'll add in bunches of three. So see, same way. We'll keep this one here. We'll take the remaining at the end, and 332 will be the recurring figure. Why? Because that one will become two because it will take one from this side, one from that will be the dividing ordinate. So 1, 3, 3, 2, 3, 3, 2. You'll keep repeating this as many times required, but end with 3, 3, 1. So please a few times repeat on your minds, just quietly. 1, 3, 3, 2, 3, 3, 2, 3, 3, 2, 3, 3, 2, 3, 3, 1. 1, 3, 3, 2, 3, 3, 2, 3, 3, 2, 3, 3, 2, 3, 3, 1. So 332 will be repeated as many times as required, but you will end 331. Like you said, 142, 422, 4242, 41. Here it will be 1332, 332, 332, 332, 331. Is that clear, beta? Clear, class? The coefficient for rule 2,
Yes, sir.
yeah, coefficient for rule 2 is 3 by 8. So every time rule 2 is used, coefficient used will be 3 by 8. Only these changes have to be made, otherwise the process for rule 2 will be exactly same as rule 1. Okay, this I have written in hand. The same thing is on the screen, the printed one in the next screen. You can take down this if you want. Okay. Whatever I have said is again here on the screen. You will not need to refer to this. Once you do a few questions, you will be perfectly fine. And when I take question number 1, which we had skipped yesterday, because there were 10 ordinates and rule 1 was not applicable. You see, for 10, rule 2 will be applicable. We'll use rule 2 and solve that. But in the diagram, I would request all of you to participate and answer as we discuss. So can we go to question number 1 if everybody is okay with, or you have any questions, guys?
Good to go, sir.
Good to go. Okay, before I take you to the question, tell me one more thing. I had explained to you water plane area, guys. Okay, so let us see what type of shape the water plane area will have. You see, if this is the ship and this is floating at this water line, then we are talking of the water plane area at the draft at which she is floating. And in my first class, I told you that if you imagine the vessel to be cut here, the water plane area would be somewhat of like this shape. Yes or no, beta? Am I correct? Correct? This will be the
Yes,
shape of the water plane area. Yes or no, beta?
yes, sir.
Correct. So, and what is the center of flotation called, beta? What is center of flotation? Besides being fulcrum, where is it? How do you, what is center of flotation?
I do study draft.
That is center of flotation. What is center of flotation?
About which the buoyancy is
That is
acting.
the fulcrum, but what is it? That
So
okay.
geometric center of water plane area.
It is the geometric center or the centroid of water plane area. Okay. So basically, if somebody says find the center of flotation or LCF, he wants you to find the distance of the geometric center of the water plane area from the after perpendicular. Correct, beta? Am I right? Yes or no? Correct, class?
Yes, sir.
So let's go to the first question. Here is the question number 1. Read the question. The breadths of our transverse watertight bulkhead at 2 meters interval. Oh, this is not the one we have to do. Okay. This is not the one we have to do. Okay, let's maybe the second question I have to discuss. Okay, I can discard it, no problem. This is the one we have to do. This that the first one we have already done yesterday. Okay. That was in your exercise. That is question number two. In my slides, I have done that as first question. Okay. Go and hit there. Whenever half ordinates or semi ordinates are given, what is recommended should you do? You should make them double and use the full ordinates. Right, guys? Correct? Correct. Question is calculate the area and the position of COF, center of flotation of the ship's water plane area, whose half breadths are at 10 meters interval from aft are given. It is 0, 6, 8, and whatever and given. If you count them, so first thing you will count them. There are 10 of them. You'll make the diagram. You can keep deciding the rule later. I've just shown you how the water plane area will look like. The water plane area will look like this. Now, why have I made these points meet? Let me use a laser pointer. Why have I made these points meet here? Because it is zero at the after end and it is zero at the forward end. That's why they have been made zero. So that's when I'm telling you make the diagram appropriate to the question. This is what I mean. If they were not zero, we'll keep some breadth there. There are total of 10 ordinates here. If you don't understand anything, let me know. I have marked these 10 ordinates at equi-spaced intervals, including the one at the ends. Now, what in my diagram have I marked half breadths or full breadths, guys? In my diagram, have I marked half
Full
breadth or
breath,
full breadth?
full breath,
Full, sir, full.
full.
So I'll double up the half breadths and get mark the full breadths. Now they are from aft, so we have to decide which one is aft. Never mind. Aft is this side, forward is this side. If somebody takes aft on the other side, that's okay. That doesn't matter. Okay. We double it up. So aftermost is 0, then 12 meters, then 17, then 17, then 15, then 13, then 9, then 5, and 0. We have these ordinates. We have doubled up. So the half ordinate thing is already finished now. I count the total number of ordinates. I find them 10. Then I ask myself a question, which rule is applicable? And I'm sure all of you would agree rule 2 is applicable. Yes, correct. Second is, guys, what does he want besides area? He wants AF or LCF. Why? Because usually when we talk of center of flotation, its location, mostly in the ships, it is given from after perpendicular. You all know that, right? Whether it's a hinge ship or any other thing, it's LCF, which is usually given. So if I have to find the distance of the geometric center from after perpendicular, that is the after end. mm, Now, which are the two extremities? One is the forward perpendicular, other is the after perpendicular. I recommended that the axis should be preferably at the extremity. Since he wants AF, so obviously after perpendicular becomes the obvious choice. Do you agree with me, guys? I'm talking to you as if I'm thinking, right? Yes or no? So after perpendicular becomes my obvious choice. That will also come up in a while. If after perpendicular is the obvious choice, a preferred choice, no, okay, you can take from wherever you want, but that's a preferred choice. So which ordinate should I write first, and which side should I start writing the ordinates from preferably?
From aft, sir.
From
0
Aft.
to
So
16.
0, 12, 16, and so on and so forth, right? Correct, beta? Right?
Yes, sir.
yes, sir.
Can you please make the table quickly in your notebooks and fill up the Simpson's multiplier before I show you? Guys, I'm not bothered. If there is one more extra class on Simpson's rules, let it be. I'm not bothered. Please, let's not just because sometimes in hurry we waste the entire effort goes down the waste. So let's not waste time, but let's not unnecessarily pressurize ourselves. How many questions to be done today? We'll do. My target is 10, but if it is 8, never mind. If it is 9, it's okay. No problem. Whatever it is. Please make the table, write down the Simpsons rules, Simpsons multipliers. It's 1332, 332, 332, 332, 332, 332, 332, and with 331. Danny, are you getting it today? You know.
Yes, sir. I got it.
Okay. Guys, are these the Simpsons multipliers you have filled in? Please see 1332, 1332, 332, 331. Right, guys? Yes or no?
Yes, sir. Excuse me, sir.
Yeah, tell me.
सर ये जो वाटर प्लेन एरिया है ये हम कहाँ से ले रहे हैं सर वाटर प्लेन
कहाँ
एरिया का
कहाँ से ले रहे हैं मतलब?
मतलब मेरे को एस्पेक्ट नहीं समझ आ रहा कि हम जो कील से है वहां से ले रहे हैं कि कहाँ से है सर
जिस ड्राफ्ट पे शी इज फ्लोटिंग है उसका वाटर प्लेन एरिया है बेटा. वाटर प्लेन
अच्छा
एरिया इज एट द वाटर लाइन.
अच्छा सर जिस ड्राफ्ट पे वो फ्लोट कर रहा है उस पे लेंगे
उसका वाटर प्लेन एरिया है ना. Yes or
ओके
no?
ओके
Unless he
ओके
gives you water plane area at draft, so and so is this much at draft, so much is so much. It will be different at different drafts, right?
यस सर
Okay. Okay, guys. Now for liver, I said, does everybody agree that after perpendicular should be the preferred axis? It has come on
यस
the
सर
screen.
Yes, sir.
So axis
यस
has come. Now fill up the livers. If you
Sir,
want to fill up, tell me.
in this case, taking by H will be good, na, sir?
Yes, it will be easier taking multiples of h, but somebody wants to take 0, 10, 20, only your numbers will increase. So your
Yes, sir.
unnecessary calculation time will increase. Okay. So as I'll again repeat, this multiple of h or no multiple of h, as a smart person, we should opt for what makes our things easier, right? Okay. So there is no hard and fast rule. Should it be taken as multiple of h or not? It is only a matter of convenience. What suits us would be our preference. And in this case, if I have to do, my preference would be multiple of h. If somebody wants to differ and wants to take absolute values, I have nothing against it.
सर
So
107.5 मीटर क्यूब एरिया है
square meter होगा, but आंसर ठीक है तुम्हारा. Just wait for a while, but ठीक है
स्क्वायर
आंसर
मीटर
तुम.
स्क्वायर मीटर
Yeah,
यस
आंसर ठीक है तुम्हारा. So liver, you look at the diagram, guys. 0 will have 0h. 112 will be 1h, 2h, 3h, 4h, 5h, 6h, 7h, 8h, 9h, and 10h. 9h. Guys, every time what I do is after I write them here, before I multiply and waste my time, I go back to the diagram. And if you develop this habit, it will be good. I count them on the diagram so that my last number matches. It should not happen that I made a clerical error and in the end I find that effort has gone waste. So 0h, h, 2 0h, 1h, 3h, 4h, 5h, 6h, 7h, 8h, and 9h, and this matches. So that means I have not made any mistake. Now you can complete, please complete POA and POM about after perpendicular. See how the axis has been reflected here and find the SOPs, please. Please complete the table and give me the SOPs.
सर SOP POA is 282
Okay.
and product of moments are 1128
28H.
sorry 1128H
Don't miss out. If you miss out, then there will be a panga. Please be careful. I'll wait for everybody to complete. You can ask me to wait if you're still doing it, Twitter. There's absolutely no hurry. And if any, okay, don't focus too much on calculations. Make sure you're in agreement with the concept. Then only move on to calculation. Otherwise, clear your doubts and then proceed with the calculations. Don't blindly just keep calculating. Don't just focus on the job of the calculator, man.
Sir, answer is 40.
Yes, beta.
yes sir
That's correct. That's correct,
Okay.
beta.
40
That's
यस सर
correct.
40
That's correct. That's correct. That's correct. Very good. That's 40 is correct, and the answer 1057 or whatever he'd given a while back, that is the correct area. Okay, anybody who is still doing the multiplication and completing table, please let me know, beta. I would be happy to wait. Class, anybody still completing the table? No? Okay, good. Makes my job easier. So area would be, now we are on rule 2. So remember, you are using rule 2. Coefficient. So I'm talking to myself and writing. I don't have to explain every time to the examiner. 3 by 8, the coefficient. Common interval is 10. SOP area is 282. And this will give you area in square meters, whatever it gives you. Then AF or else, okay, it's there, okay, it's printed, okay. It's 1057.5 square meters, okay. Then LCF or AF, whatever you want to call it, AF or LCF will be equal to moment of this water plane area about after perpendicular divided by area. How will you get the moment? 3 by 8 into H into SOP moment. 3 by 8 into H into SOP moment 1128 H. This 10 is for H. Divided by area. 3 by 8 and 10 get cancelled out and you get LCF of 40 meters. That's the second answer. Is it clear, beta? Is that clear, class?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay. So I'm moving on to the next question. If somebody wants me to wait or explain, please let me know. Don't lag behind. If you lag behind, then you'll miss out whatever is being spoken about thereafter.
सर एक स्मॉल डाउट है सर
Yeah, tell me.
जैसे पेपर में ये क्वेश्चन आता है एंड लाइक वी डायरेक्टली फाइंड आउट द एएफ एंड वी राइट इट आउट एंड वी डोंट राइट दिस फॉर्मूला लाइक यू हैव रिटन सर तो सर नंबर कटेंगे क्या और
नहीं
फॉर्मूला
कटेंगे, नहीं कटेंगे अगर सही किया है तो, but there
फॉर्मूला
is a
लिखते हैं
reason because if you use rule 3, then you can't divide the SOPs beta because
ओके
there the coefficients are different. You'll understand the why I'm emphasizing on the correct method is so that you never get stuck. Anyway, it's
ठीक
your choice.
ठीक
You are saying I'll divide 1128H by 282. That's what you're saying. But tell me one thing honestly, how much time it takes here? Does it take time?
नहीं टाइम नहीं सर अगर वैसे पूछे सर
नहीं नहीं, तो बेटा जो टाइम नहीं है अगर सही ढंग से करोगे इट विल मिनिमाइज द मिस्टेक पॉसिबिलिटीज. यू डिवाइड इट्स ओके, नंबर नहीं कटेंगे.
ओके
To
सर
answer your question, okay guys, so now we have completed the first three questions of the exercise. Question number 1, this was question number 2 now on display, which you're seeing we did yesterday with pressure and thrust. This was question number 1 of the exercise, and this was question number 3 we had completed yesterday. And here we do, we divided the total area into two, the distance of the geometric centers, each one of them from XX, and then we combine them by principle of moments. So please remember this concept. We'll be using it repeatedly. Now we come to this question. Then the next question. Now they'll be in the same order in the book. Guys, find the KB. Now, first three questions were on area. So through in these three questions, what have you learned? If it is a vertical structure like bulkhead, how the diagram should be made. If it's a horizontal thing, water plane area, how it has to be made. Okay. Now we, for the first time, we come to where ordinates given are areas. And if ordinate is area, the output would be volume. He says find the KB, distance of the center of buoyancy from keel, and the displacement at 4 meters draft in seawater if the water plane areas against these drafts from 5 meters to 0 meters are given here. Okay. Now, guys, Water plane area is a two-dimensional thing. It's an area, and I have to show multiple areas. I can't show in a two-dimensional diagram. Okay. Now you tell me, if I make a diagram here, I'll clear the screen later on, don't worry. Tell me, beta, will the water plane area at any draft, will it be parallel to the bulkheads or will it be parallel to deck and keel? Will the water plane areas be parallel to deck and keel?
Deck and keel.
Deck and keel. And when you see from the side, how is the deck being seen or keel being seen? As a straight line, correct? Yes or
Correct,
no?
sir.
And
Yes.
every deck has an area, right? Yes or no?
Right.
But what can you see? You are seeing deck as a straight line. So if you see draw in a side elevation, water plane areas will be drawn like this. Now they are not lines, they are actually areas. Understood? Because they will appear like this in a 2D diagram. Am I right, beta? Correct, beta?
सर ये डिफरेंट ड्राफ्ट के डिफरेंट वाटर प्लेन का एरिया है ना सर?
Of course, if you take a different draft, they'll be different. No, you agree with me that water plane area will keep changing with the draft. Yes or no? Correct?
Yes sir.
So you can make this diagram if you want, or you can make the cross-sectional view. Choice is yours. Only one diagram you have to make. In the cross-sectional view, this is the deck. If this is the deck and this is the keel, then water plane areas will be shown like this. Does everybody agree, beta? Am I right? Clear? Clear, class? Okay. Before now, what is displacement equal to? What is the formula for displacement, beta? What is the formula for displacement?
Volume into density.
Which volume?
Underwater volume.
Underwater, up to the water width. Okay. And what is center of buoyancy, guys? Can you define center of buoyancy?
Point at which buoyancy acts upwards.
But what is it? What is it?
Geometric center of
It is the centroid. It is the centroid or the geometric center, technically, of volume of buoyancy. What is volume of buoyancy? The volume that provides buoyancy. Okay. But in an intact ship, it is same as underwater volume. So in this topic, if you say that it is the centroid of the underwater volume, that is also correct. But technically, it is the centroid of the volume of buoyancy. Is that clear, beta? Okay, so that means now we have to find the distance of the centroid of the volume of the buoyancy or underwater volume from keel. And guys, if I want the distance from keel, then what will I have to do? Will I need the moment of volume or moment of area now? I'll need moment of volume. Correct, beta? Moment of volume divide. See, in first three questions, we had the moment of area divided by area to get the distance. Yes or no, beta? In question number 1, 2, and 3, correct? Correct?
Yes sir. Yes sir.
If I want the geometric center of the volume, then it will be the moment of volume divided by volume. Do you all agree? Keel. So it will be moment about keel divided by volume of displacement or volume of buoyancy. I've already explained to you how the diagram in this case can be made. Either you can make a side elevation. You don't have to at different drafts. 0 meter, 1 meter, 2 meters, 3 meters, 4 meters, 5 meters. Water plane area is 780 at the keel, 920, 1300, 1580, 1920, and 2010. At what draft does he want the displacement, guys? Look at the question.
4 meters.
4 meters. So do we want the underwater volume up to 4 meters or 5 meters?
Up to 4 meters.
So that is where it is needed to be careful in reading the questions. Okay. Otherwise, in a hurry, you may end up calculating full thing. Somebody want to make a cross-sectional view. I'm just showing it so that next time when water plane area comes, we are not again struggling with the diagram. These are the water plane areas. What is the volume of our interest? Volume of interest is only up to 4 meters. This is the volume in the side elevation. This is the volume in the cross-sectional view. Does everybody agree? Correct, beta?
Yes.
How count in the diagram how many ordinates bind the volume of interest? How many? Count
Five.
them on the diagram.
Five,
Five.
sir.
Five.
Five.
Which rule is applicable? Rule
Rule
one.
one. Rule one.
Correct. Correct.
Correct.
Okay. You want KB. So what will be your axis of interest?
Keel.
Keel. Very good. Very good. So keel will be the reference axis. So you can draw the reference axis here as keel. See now the table. Ordinate, I'm sure all of you agree. Simpson's multiplier, you can fill up. Now it has become product of volume, not product of area. Please take note. We are taking liver about keel. Why keel was preferred? Because the question wants KB, and then we'll get moment, product of moment about keel. Product of moment what? Volume. Can you now please write down the ordinate in the preferred order, complete the table, and get these values? I will show you the in-between table later on once you complete. I have given you a check. SOP volume I have given and SOP moment about keel I have given you. And here, whatever doubts you'll have, I'll answer that. How much is H, guys, before you start? What is the value of H in this question?
One, sir. 1 meter.
1 meter.
Okay, the spacing between the ordinates is 1 meter, correct. So whether you take it as 0H, 1H, 2H, or you take only 1, 2, 3, 4, it's the same. So why unnecessarily bring in H here when it does not make sense here? H is 1. So now complete it, please. And if anybody is getting stuck, let me know.
Sir, KB is coming 2.322 meters.
ओके बेटा, अभी दिखा देते थोड़ी देर में. वैसे तुम्हारे पास जो फोन में मैंने एक्सरसाइज भेजी उसके नीचे में आंसर भी है. ओके, आई हैव सेंट यू द एक्सरसाइज इन द फोन, and if you just scroll down at the end, you'll have the answers also. Okay. Okay, have you got these SOPs, guys?
Yes.
Okay. Anybody still in the process of getting? I'll wait.
Calculating.
Okay, let me know once you're done. Anubhav, once you complete, let me know, please.
I have done, sir.
Okay. Whosoever said he's still doing, once you're done, let me know, please. Okay, never mind. Sorry.
Done, sir, done.
Okay, good. If anybody wants to compare, you can compare the entries 14241. Liver for 780. Look at the diagram. Is the reference to it will be 0, 1, 2, 3, 4, and you get these. There's no h taking multiples of h does not seem to be solving my issue. And now we come to the final step of the calculation. Please calculate the volume. I know some of you have already calculated it. Okay, so the volume of buoyancy will be equal to we have used rule one into SOP volume 15300. This is 5100 cubic meters is the volume. So the displacement at 4 meters draft will be equal to 5100 into 1.025. And now I'm showing the answer I'm picking up from there. It is 5227.5 tons is the displacement answer. KB at 4 meters will be moment of the volume about heel divided by volume. Moment will be rule 1 by 3, common interval 1. SOP moment is 35520 divided by volume 1 by 3 into 1 into 15300, and this will give you an answer of.
Yes, sir.
I give another 10, 15, 20 seconds for everybody to make sure you absorb it, and let me know if there is any concern or anything bothering you on this part. So now you know if the water planes have to be shown in a diagram, you can either make this one or this one. Most of the times I found people preferring this one because this takes lesser time, but you can make whichever one you want. Okay, anybody who wants me to wait and not move on to the next question yet? Anybody in the class, guys?
Next question, sir.
Okay, next question. Good. Okay, I've not cleared this. Let me clear this then. Let me clear the next one also. Now, here is the next question, guys. Draft is given up from keel to 6 meters and TPCs are given. Find the displacement and KB at 6 meters draft in seawater. Density has to be taken as given. Now, guys, you cannot integrate TPCs. We have already said it. The line is the input, output is area. For displacement, you need volume. For volume, the input has to be area, nothing else. There cannot be anything else. So basically, your basic formula for TPC you must remember and should be able to recall. We all know that TPC of a ship is equal to water plane area. A is the water plane area at the draft at which ship is floating upon 100 into the density of the water in which she is floating. Yes or no, beta? Am I right? Correct, guys?
Yes, sir.
So from TPC, you can get water plane area at different drafts because the TPC at different drafts is given. You can cut from the TPC at different drafts, which is given. You can get area. Area will be equal to TPC into 100 on density. And once you get the water plane areas, then it becomes like the previous question. Correct, beta? Am I right?